Hi, welcome to class and welcome to this lecture. I'm Christine Pence, and this lecture is What is Science? What is science? This very first lecture is meant to give you an overview of the big questions that we are going to cover in this course. But before we go there, take a look at this painting. A philosopher giving that lecture on the orrery in which a lamp is put in place of the sun. The painting captures a moment during a nighttime lecture given by a science teacher, a philosopher. He is surrounded by an interested middle-class group made up of men, women, and children. The hoops arcing over the center of the painting are an orrery. An orrery is a clockwork-driven model of the solar system. The planets go around, and at the center is a lamp standing in for the sun, casting light on the surrounding faces. The painting, by Joseph Wright of Derby, was made in 1766 for a possible client, a relatively rich British naval officer. And there's a lively discussion about the art historians about who the folks in this painting actually are. But what I want you to see is the beautiful glow of the center lamp on the faces of the fascinated children and the relatively youthful faces of all around. These young people are fascinated by a lecture and an instrument that explains the workings of the universe to them. It captures what we think about when we think about the allure of science. Whatever else the course is about, it is about the awe and wonder of studying the natural world intently and intensely. Then, look at this article which appeared in 2023 in the magazine The Week. Here is Bobby Wilson, a little girl who joined the New Jersey State program to kill lanternflies. And they were flying around her neighborhood in her home in Caldwell, New Jersey. She was spraying infected trees and collecting the bugs. As she started work near one of her neighbor's houses, that neighbor called the police because he didn't understand what Bobby was doing, and he saw her, a 9-year-old girl, as a threat. And as a result of that call, the police did in fact come to question Bobby. It was a horrible moment. But the story has a happy ending. Bobby's family spoke up at the town council. Then Ijeoma Opara from the Yale School of Public Health championed Bobby, and Bobby's work was then recognized by Yale. She received mentors, Black women scientists. This painting and this story frame some of the issues we will look at as we explore the history of science. Now, this course is going to ask 5 big questions. And this lecture is going to illustrate those questions with some stories and some ideas. You'll want to keep this lecture in mind as you view the other lectures in the course. What is science? Who does science and who can do science? What is scientific progress and who is science for? What is the relationship between science, technology, work, art, and the imagination? And what drives change in science? Well, really, let's start with what is science? Science is revealing mysteries. For instance, where does lightning come from and what is it? That question was famously investigated by Ben Franklin, who put up a kite with a key on it. What moves things downward and how fast do they travel? That's been investigated by dropping objects from towers and using a pendulum to measure time. Where are the stars and what are they made of? That's been investigated by telescopes, taking increasingly powerful images of stars increasingly far away. How does a horse gallop? In what order do its feet touch the earth? That question wasn't solved until the advent of the camera. Science is about mysteries that we chase down with instruments and observations. And this is the definition that I'm going to offer for this class. This is the definition I'm going to offer for this class. Science is the attempt to uncover hidden forces, unknown causes, and effects by using specialized observation techniques and specially built instruments for the purposes of controlling, directing, and predicting those forces. Now, you don't have to memorize that, but we're going to walk our way through it multiple times in this class. Our definition is going to allow us to look at a whole series of cultural activities and see how they fit into the pursuit of science. As we go forward, you'll see why this definition will help you to understand science in a clearer and more precise way. Also, In our definition, the word forces is particularly apt. One of the big modern organizing ideas about the universe is that there are 4 known forces in the universe: the strong force, the weak force, the electromagnetic force, and the gravitational force. By the end of our course, we'll have looked at all of these 4 forces model, and we'll be thinking a little bit about how we know it's true and how we've demonstrated it. Before you go on, if you look at the notes for the lecture, you can see some examples of the 4 forces and the standard model of particle physics. I have a couple of links to some good websites there. And as a footnote to the definition of science, I will tell you a story. This is a memory I cherish. Long ago, I was on a committee that was going to offer a scholarship to a student. And we had a number of students come into the room with the committee, and they were all nervous, and they all were well dressed, and they were all very prepared for their answers. And the last student who came in did not seem nervous, and also didn't seem like all the others. In fact, he seemed potentially to be fairly high. And so the group looked at each other kind of around the room and a little bit surprised and upset that a student would come in this way. And so one of the committee members was a little rattled and a little angry about this. And so instead of asking the prepared questions, instead he said, "What is the purpose of modern science?" And the student paused. There was a long pause. You could almost see the wheels slowly turning and his brain moving up a level into a higher gear. And then he answered, "To reduce guessing." There was a silence. I wanted to laugh, but I didn't dare. It was a perfect answer. What else is science for? He didn't get the scholarship, which to this day I think was too bad. I hope he went on to great success. And he was right. The purpose of modern science, as far as I can tell, is to reduce guessing, to use information to help us shape more accurate answers and ideas about the world. At the end of the course, I hope to convince you that we are still on a journey. The story of science is not, "and now we know." It's rather, "Here's what we think we know, and here's why we think so, and here's what we still don't know and are still trying to find out." Science is a chase, a dance, and the whole universe is our playmate and partner. Who does science, and who can do science? We tend to treat famous scientists as if they are Einstein, party of one. They are seated at a table alone, brilliant, individual, unapproachable. Now, you won't hear me saying that brilliant isn't brilliant. I fully admire insights, breakthroughs, diligence, and discoveries. And just for interest's sake, you can take a moment to survey some Nobel brilliance in our notes. I have a list for you. But in a later lecture, you will hear me saying that no one is successful without help. And some successes and breakthroughs were being earnestly sought by more than one person, and more than one person can claim them. Typically, one person amongst them did a better job of framing successes around him or herself, and we'll take a look at that. We'll see Marie and Pierre Curie and Rosalind Franklin, as well as Elon Musk, when we talk about who is famous and why. And one more question to ask is, who is given money and leisure to observe the natural world? Another is, who is so drawn to questions and problems that they make a way and join what otherwise might have been an elitist conversation? They just elbow in. So who is given time and training and who is not? Who is invited in and who is kept out, and why? These answers aren't straightforward. As we will see, enslaved people did science, scribes did science, pre-Columbian cultures in North America and Mesoamerica did science, women did science. The doors aren't and weren't only open to European or Western men. But science requires passing on observations for consideration and reobservation, so literacy and developing a literate population becomes a part of the story of science. The image on the left you already know. This is Bobby, who was collecting specimens for a science project. The image on the right you might not know. It is created by Justin Kerr. It comes from an online Maya vase database that he built. You're looking at a picture of a Mayan scribe, one of the sort of people who learned to track the stars and time and to illustrate tremendously long calendars. One of the important questions for this course, and for your life, is how exactly do we define progress? Because progress can be defined in terms of a tool, or it can be defined in terms of our well-being. If you look at the phone, you can see on the left the phone with a receiver and a wire, and then on the right a phone, handheld, wireless, connects to the whole world. On the left below you can see a stool, that's a medieval stool, sturdily on 4 legs, or on the right-hand side you can see a rolling chair that makes you feel like you're floating. These are tools that got better, tools that are more suited for their purpose. But if you look on the bottom left, you can also think about medicine. Something like better access to social good, cheap, effective medicine for everyone, or maybe access for communication to people living in distant cut-off places. That's not just in terms of the tool, but in terms of better living. You might think about a quantum computing tool that might help you figure out what's going on in the universe, but it might also help poor people to contribute to banking because there's better data that's more accessible to everyone. Enhancing human potential, giving a precise result, facilitating positive social change. These are some ways to talk about progress, and you'll want to think about that. Well, after we've asked ourselves what scientific progress is, we also want to ask ourselves, who is science for? Should science, for instance, be directed by governments or by companies or by universities? You're probably too young to remember the DuPont slogan, "Better things for better living through chemistry," or what most people who do remember it will say, "better living through chemistry." There were many and various cheerful promises that companies in the 1950s made on behalf of science. And they were cheerful in the face of the new nuclear weapons and an actual political strategy of mutually assured destruction. Now, in the 21st century, there's a lot less good cheer going around. The planet getting hotter and hotter, lots of tensions around who defines progress and who it's for. There have been some pretty horrifying unintended, unanticipated, or unconsidered consequences to our discoveries, and developments that make the debate around science pretty fierce. And we're going to look at some of those debates. I myself have a mental marker of progress in a very humble moment in 1969. It's the 10th time when the heavily polluted Cuyahoga River caught on fire, because it wasn't the first 9 times that they set the river on fire, but rather the 10th time that convinced the citizens that they had better stop putting chemicals into the water. Would you call that progress? I do. You may note in the DuPont image an implied religious symbolism, a golden halo around a pure white spiritual being, chemistry. Science is pictured as a saving force. Now, in some versions of the history of science, humanity makes progress by leaving religion or religious explanations behind and adopting scientific explanations of events and forces. After the Enlightenment in the 18th century, religion is sort of relegated to the realm of emotional or even irrational beings. It's fit for telling children moral stories. Maybe it's good for an occasional solemn ceremony, but it's not good for science. I'm not going to be telling this story of science that way, because, as I said, I see science as a great chase, and I also think that what we don't know far outweighs what we do know. Thinkers in religion also try to uncover the hows and whys of our lives. They're also chasing answers. We will review some of the major thinkers who have different opinions about how science relates to religion. We're also going to be asked, what is the relationship between science, art, technology, work, and the imagination? This is just too big a question, but for now I want to emphasize that these spheres of interest aren't opposed, instead they overlap. For instance, some cave paintings were drawn in a single flowing line. The artist knew the subject deeply and had drawn it so clearly and so deftly that we can identify a species from 20,000 years ago. And more, they added graphic markers, you can see 4 lines in a rectangle above the horse's head, to indicate more information about the animal. So scientists and artists are united by the habit of observing carefully and accurately. If someone sees something new with an instrument that is not well understood or not commonly used, like the very first telescope that Galileo used, how is the rest of the world going to be convinced? How do we all change our minds and see the sun at the center of the solar system? Was it logic that convinced us? This is called paradigm shift, and it is a social question as well as a scientific one. Now, what about science and work? As you'll see in upcoming lectures, science is often recruited to support the technology that solves basic problems that most societies have to solve. Like, when do the migrating animals come back that we eat? How long till it's warm again? How do we move water to where we need it? Where exactly are we, and how do we get back to where we've been? Science and technology are always interacting. On the left is a flood control system built 2,000 years ago in China. It's the Dujiang River Causeway, and it's still working well today. On the right is a series of windmills from Iran, built 1,000 years ago. So to the degree that we want work and life to be easier, we employ science. Lifting, crushing, hauling, shaping, storing energy in all forms, or redirecting energy from one form to another. All of this is done in the effort to make work and life simpler. For that matter, controlling the weather is a huge human effort. No one wants to be too cold or too hot or too wet or too dry. Some of the earliest records and tools developed in science were directed at the basic control of the environment and weather. But sometimes science is recruited to do things that no one really needs done. It's just this. Those in power want to display their power. Big buildings, big communal efforts in particular, these are sinks of wealth. Time, energy, labor, and thought are so embedded in a place in a monument that they are fixed until the end of any foreseeable future. The Hagia Sophia, or Stonehenge, or the pyramids, the moonshot, there's no way to repurpose the energy and time that went into those efforts. They display power, wealth, and ambition, facilitated by science. Finally, what belongs in the history of science and what drives change in science? As historians, we have the duty to decide what truly happened, what's significant, and if we're looking at what's called an inflection point. And as we go along, we'll be asking those questions. How do we know what happened? Why does it matter? Could it have happened any other way? That's the essence of historical thinking, and in this course we will try our best to pick out what actually happened and how we know it did happen. We'll ask what matters in the history of discoveries about the world, what choices we have, then and now. And now the last part of our question, what is the process of change? I will argue that in the history of science, people argue with practical or intellectual problems. Observers at the bottom of our chart here wrestle with problems that they want to solve, and they solve those problems with specially built instruments, telescopes, microscopes, and then they use those instruments to change the story of how the universe works in big organizing ideas. And as we move forward in time, we'll iteratively move through groups of observers, practical and socially constructed problems, the development of new instruments, and big organizing ideas. Progress is not linear. It's not necessarily the case that knowledge is found and stays found. Some ideas and developments are lost. Some ideas do not persuade others of their value or truth. So this model will help keep us grounded in the context of discovery so that we can identify with people who wonder about the world, who have real struggles and face daunting problems, who convey their ideas to others and persevere in persuasion. As with any story, not only personal grit, but communication, power, and resources will drive the turning wheel.